Hello again, and welcome to today's webinar. My name is Rohit Pujari. I'm a Partner Solutions Architect with AWS. Today we have our guest, Gary Mikula, who is a Senior Director for Cyber Information at FINRA, to share with you how FINRA gains real-time insights to safeguard U.S. financial system with Splunk on AWS. We also have Felicia Dorn, who is a Product Marketing Manager, and also Patrick Shoemate, who is a Solutions Architect at Splunk, to talk about their partnership with AWS and the deep integrations they have built with many of the AWS services. Just a reminder, as we go through this presentation, you will have the opportunity to ask questions through the chat window. We'll try to answer as many of them as possible in the hour we have, and the event that we're not able to answer your questions today, we'll follow up with everyone individually via email. Also, this webinar is being recorded. The slides and the link to the recording will be sent out in 2 to 3 days after the session. So keep an eye out for the email. With that, let's begin. So when we look at where we are today in terms of all the enterprise class technology that's available to us, it's never been easier and less expensive to collect, store, and analyze massive amounts of data and share that data in the cloud. Some of that has to do with the fact that cloud provides a lot of cost efficiencies, but a large part has to do with the fact that AWS offers much richer set of analytic offerings than you will find anywhere else. Customers can do anything from Apache Hadoop, Spark, Flink, Amazon Kinesis, Athena, and AWS is significantly investing in machine learning and artificial intelligence through our services like SageMaker that makes it easy for data scientists to be able to build, train, and deploy machine learning models. And we also want to give the power of AI in the hands of developers by offering them application services that they can use without any background in data science per se to analyze unstructured information like video streams, images, and text, and also potentially build conversational interfaces with Amazon Lex, the technology that powers your Alexa devices. And organizations who are already taking up the capabilities we just talked about are able to generate business value from the data and are organically outperforming their peers. In an Aberdeen survey, we found that organizations who have implemented data lake outperform similar companies by nearly 10% in annual growth. And these leaders are able to do advanced analytics like machine learning over high volume data that's coming from not only just their IT infrastructure, but also from social media and internet connected devices. And they are using this data to gain comprehensive insights into all aspects of their business so they can identify and act upon opportunities to drive business growth. Starting with the fact that they can use data to improve user experience when and while customers are interacting with their brand, either through direct use of their products and services or through their customer support channels. And these companies are better positioned to attract and acquire new customers because they can target them with highly relevant, personalized, and actionable information. And they're also very well positioned to retain those customers because they know exactly where their customers are suffering on an individual basis. So not only they are able to understand them, but they're also able to do everything they can to win them back. And finally, they are able to use data that they have to predict the data they don't have and bring interesting use cases to bear. So for example, given an attributes of transaction, what is the likelihood of it being a fraud transaction? So they're able to predict those types of future data points based on the data they already have and are able to change or create a wave in the industry that has been never written before. So for the data to be differentiator, it's really important to the fact that not only customers are able to just sit upon that data, but they should be able to analyze ever-increasing complexity of that data. And we see that traditional approaches that worked in the past are not sufficient, or at least don't work for the newer and more advanced forms or newer forms of data that we see on a day-to-day basis. First, the volume of data is growing at an exponential rate, with machine-generated data from connected devices is growing at least 10 times faster from traditional business applications. This makes it really impractical for customers to purchase larger and more powerful hardware every time they reach their storage and compute capacity limits. Also, as data grows, moving massive amounts of data between different analytic systems is simply impractical. Second, the types of data that is available today ranges from a traditional operational data that is organized in structures and tables and columns to data being generated by newer sources like social media, mobile apps, and devices. And what we've seen is customers can no longer constrain their analytics to only one type of relational data. They need to be able to store and analyze any type of data, including relational, non-relational, without solid defined relationships or schema. And third, customers should be able to leverage data as it is generated in real time. Customers need to go beyond analyzing just historical data, but then transition to analyzing data as it becomes available. If you look at traditional analytics looked very much what we see on the left-hand side. It was a run through some sort of a relational data warehouse that collected data from multiple source systems and produced operational reports. And this method of analytics had few characteristics. It was optimized for relational data sources. It was difficult to scale. It scaled up to petabytes. And it had a rigid schema in place. It required defining the questions needed to be answered prior to the data warehouse design, because the schema had to be created based on what fields seemed important in answering those questions. And it, although enabled operational reporting and insights, but it came with high, not only capital, but also operational costs. And the variety of data today's organization generates, as you know, is causing pressure on these traditional data warehousing systems. And to relieve IT of that pressure, they need to really start investing into extending their data centers, where they can capture and store both relational and non-relational data at exabyte scale. This includes storing data that is coming from applications and devices in its native format with high availability, durability, and at lower cost. The traditional data warehouse simply wasn't optimized for storing all this non-relational data because it was designed for typically relational structured data sets or petabyte scale. And once the data is durably stored, customers should be able to catalog it, enabling them to discover what data sets they have and what analytics on top of it. And furthermore, they should also be able to secure that data to prevent unauthorized access to it. The traditional data architectures weren't built to account for these types of characteristics. The data existed in silos, or even if they centralized into enterprise data warehouse, it was extremely difficult and costly to build a custom ETL to be able to run analytics on it. And finally, customers should be able to perform all types of analytics, whether it's batch, real-time, predictive, or prescriptive. In other words, they need to operate in an environment where they can easily answer questions about what happened in the past. They can run historical models, forecasting techniques to understand and answer what would happen in future. However, the traditional architectures accommodates only for their operational reporting and ad hoc analysis on that relational data. In short, customers need data lake or capabilities that can fit into the data lake model, where they can easily access and analyze data in a variety of ways and tools and frameworks of their choice in a high performance and cost-effective fashion. And they should be able to do that without being able to move large amounts of data from one place or one system to another. And customers need to step beyond visualization and insights from operational reporting. They need to step into the land of artificial intelligence and machine learning to be even provide more insights and more actionable prescriptive analytics on that data. AWS provides, if you look at our portfolio, the number of services we have the choice for the most comprehensive, secure and scalable and cost-effective portfolio of services that you have to build your data lake and apply a variety of analytic approaches to your data. And as a result, there are more organizations today that run data lakes and analytics on top of AWS than you will find anywhere else. Customers like Netflix, Zillow, NASDAQ, Yelp, Irobot, they're all using data analytic services on top of AWS. And today we have FINRA to talk about some of that. And FINRA is trusting on AWS to run their analytics workloads as well. Well, not every conversation is complete or is buttoned up without being able to talk about security. And at AWS, security is our job zero. Without security, we don't have a business. And with that in mind, AWS has achieved a number of internationally recognized certifications and accreditations that truly demonstrate our compliance with third-party assurance frameworks, like ISO 27017 for cloud security, 27218 for cloud privacy. We also have SOC 123, and customers can be HIPAA and PCI compliant on AWS. We sign business associates agreements to get into the HIPAA compliant workloads. We've also achieved a number of public sector certifications like FedRAMP for moderate and high level government systems, which also validates our compliance with FISMA and ITAR. And we are constantly looking into future and asking our customers around what certifications will define future. And we'll continue to iterate on that by working backwards from what our customers tell us. And AWS is available today in 18 regions around the world. Customers can take advantage of 55 availability zones to deploy their applications. In AWS, we have this concept of a region, which is physical location around the world where we cluster our data centers. And within each of that region, we have multiple availability zones, which are logical data centers that are physically isolated. They're connected with dual supply, with redundant connectivity, and they're also located in lower floodplains. So this entire redundancy offers resiliency in the events that we get into an event with a disruption. So you can be sure that you can use these building blocks and also our highly available infrastructure to deploy our applications. And for instance, customers are using S3 as their primary technology to build their data lake. And S3 is taking advantage of the building blocks of AWS to provide infinite scale storage, which is able to achieve 11 nines of durability and 4 nines of availability. You can store any amounts of data, and you can retrieve any amounts of data from your applications and also through your analytics services. Now, let's hear from Splunk about their relationship with AWS and how they are helping customers to gain real-time insights on top of AWS. Take it away, Felicia.
Hi, everyone. My name is Felicia, and I am here to talk about how Splunk has made it a mission to simplify and modernize IT, and also how Splunk and AWS work together for our customers to be successful. Businesses are under a lot of pressure these days, and the rise of an on-demand economy has led also to the rise of digital businesses, which means companies need to be more agile and innovative. IT is on the hook to provide technology and services to meet and exceed customer expectations. This, in turn, has often meant taking on transformation initiatives and adopting new technologies to drive competitive edge. But IT has to manage this all on a flat or shrinking budget, which often leads to cost optimization projects. And with so many different moving parts, this is not an easy ask of IT. IT faces a constant challenge of managing increasing complexity. This complexity obscures visibility and complicates the ability to maintain performance and avoid downtime. With this comes risks of ineffective systems, poor customer experience, and overburdened IT staff. If IT can't see across domains, that is a real problem. Today, it's more important than ever to provide customers with great and easy experiences. If customers have trouble completing transactions or if apps are slow and laggy, it can really impact a company in a negative way. Without visibility into app lifecycles and insights, you risk slower release cycles and not being able to roll out all the feature updates your customers want. Instead, what if you were able to take advantage of the data in your systems to help speed up release cycles and improve features and quality at the same time? With Splunk, you have full visibility in real time to the development teams and what they're working on and the quality of releases based on testing results. You can use your machine data to become a data-driven enterprise. Using data, our customers are able to avoid outages, improve customer experiences, and provide agility to roll out faster release cycles and feature updates. Customers that have gone down the journey with us have achieved predictive IT and have gained competitive edge through fast innovation. So what makes Splunk different? The beauty of how Splunk works for IT lies with these 4 key features. Splunk is able to ingest, analyze, and execute IT use cases against any type of machine data at massive scale across the full stack of IT. Onboarding data into Splunk, including metrics, logs, and events, is fast and simple to configure. Next, Splunk is open and extensible, which allows insights to be created from new types of data very quickly. Splunk's universal platform is ideal for data-driven troubleshooting, monitoring, workflows, and insights at any scale. Splunk goes further with advanced analytics and AI, allowing event correlation with machine learning to provide real-time and predictive insights. This helps eliminate outages, poor customer experiences, and revenue-impacting incidents. Lastly, from troubleshooting, monitoring, root cause analysis, all the way to event management, predictive analytics, and executive visibility, Splunk does it all and from one single platform. Splunk provides continuous visibility to business performance and across IT domains to empower customers to decrease time to market, prevent service disruptions, and predict potential issues. Now, let's talk about Splunk with AWS. Together, we have over 7,000 joint customers around the globe, spanning across different sizes and verticals. And how can companies get their AWS migration right? With Splunk, here's our approach. As companies migrate to the cloud, end-to-end visibility is essential before, during, and after the switchover to maintain insight into performance. And now, more than ever, it's critical to monitor performance across hybrid architectures with tools that collect and correlate data from every location. Splunk enables you to keep up. Next, having a single monitoring solution that provides dashboards to multiple audiences from the same data can unify and make the transition to the cloud as easy and simple as possible. And lastly, migrating to the cloud can offer huge cost savings by reducing server ownership and management. Cost management tools offer current and historical instance usage and show unused resources. The Splunk app and add-on for AWS helps you gain end-to-end visibility across your entire AWS environment, helping you move mission-critical workloads to AWS with agility, security, and confidence. The Splunk add-on for AWS gets your data into Splunk, while the Splunk app for AWS provides users with dashboards, visualizations, and alerts right out of the box. It offers a rich set of pre-built dashboards and reports to analyze and visualize data from over 15 AWS data sources, including AWS CloudTrail, AWS Config, Amazon Lambda, and all from a single free app. As you can see, Splunk ingests a plethora of AWS data sources and services to help you meet your toughest IT, security, and application delivery challenges. One of our newest integrations include the Amazon Kinesis Data Firehose, and I will hand it over now to Patrick to talk more about it.
Let's start with building up to our demo. Kinesis Data Firehose is an Amazon service that connects streaming data sources to other services and other targets. But Firehose batches those streams up for delivery. Today, there are 4 targets for Firehose: Amazon S3, the object store, Amazon Redshift, the BI database columnar store, Elasticsearch service, and Splunk's own HTTP event collector. The HTTP event collector is exactly what it sounds like. It's an HTTP endpoint that you can post authenticated messages to, and that data will automatically be indexed into Splunk. We'll work through a demo of that in a couple of slides. One of the nice things about Firehose is that so many things can talk to it as an emitter, and then it does all the heavy lifting of translating those streams delivering that to the HEC, or the HTTP event collector. So this creates an easy to use and expensive collection and transmission of data into Splunk. Everything from VPC flow logs, Lambda, EC2, IoT streaming data, as well as your kind of bread and butter events like CloudTrail, AWS config, and even Trusted Advisor can be shipped into Splunk now. Firehose will store and forward events and as well ensure delivery. Let's go on to this demo. So we're starting with the HEC configuration inside Splunk. I've got a couple of tokens set up and source types for each one. Next, we go to the Firehose console inside Amazon. I'm going to create a new stream, a common sense name here. Got to get rid of that N. And then next, this is the transforms page. We're not going to be using those today, but they're very, very powerful. Select Splunk as the target. Define the HTTPS endpoint. A valid cert is required here, so a self-signed cert will not work. I'm going to switch to event endpoint. Event assumes JSON formatting for the payload. Drop in the authentication token from the Splunk configuration. And then define an S3 bucket for any event that cannot be sent to the HEC correctly. I'm going to turn down the buffers here so we get data quickly. I got to set the IAM role. An IAM role, it allows the Firehose service to perform functions for you. Check everything else looks okay. Create that delivery stream. Next is configure CloudWatch events to send CloudTrail data to the Firehose. Select the Firehose that we just configured. Create a new role, give it another common sense name. And then we'll switch over back to Splunk to see the data as it starts flowing in just a few minutes. There we go. So this demonstrates that the second one you do, it'll take you 5 minutes to set up a new data source. The first one, you have to have the certificate, have to have the HEC configured, that kind of stuff. So slightly higher drag for the first one. The second one's almost free. Oop. And many clicks later. All right, so that's the how, what. The AWS Marketplace provides us a bit of a simpler solution. The cloud has given us the ability to skip the 6-month delay from when you need a server to getting it rack stacked, powered, and configured. Marketplace does that for procurement. So Splunk is available on the AWS Marketplace in several ways. Everything from bringing your own license, Amazon machine images, to hourly pay-as-you-go subscription services, to bring your own enterprise licensing, or bring your own enterprise licensing agreement with you as a private offering. So Splunk Enterprise, Splunk Cloud is available, Insights for cloud monitoring, as well as the brand new Insights for infrastructure are all available via the marketplace. So that's the what, the how, and the where. Now let's switch over to Gary from FINRA as he puts it all together and talks about the art of the possible and how his team uses Splunk to shift left.
Thank you, Patrick. So I think Patrick gave a great lead in there because we've now talked about both vendors, and what I want to share with you is exactly how we actually implemented at FINRA and how we have it working and what benefits both AWS and Splunk are bringing to the organization. Again, I'm Gary Makula, and I manage a group of engineers here at FINRA, and we're trying to keep up with the speed and the scale of the cloud. And that's probably something that other people are wrestling with. And we've been doing that, or trying to do that, since 2014, when we became both an AWS and a Splunk customer. And what you realize very quickly when you move to the cloud is that traditional methods just won't keep pace. And eventually you have to decide that you're gonna have to shift left. And I have a framework for what shift left means, so we're all on the same page. And that is that there are 3 steps to it. The first one is that you have an automated workflow. And so no more manual, hands-on type of configuration. Secondly, that workflow and what you produce has to provide instant feedback to the people who can actually, the people and the processes who can actually affect changes whenever state changes. And finally, when you do that, you're building a culture of problem solving by getting the information to these people that they need in order to accomplish the corporate goals. And I'm going to show you how we integrate both AWS and Splunk to do just that. But I'm sorry, I have a couple of slides just to tell you who we are, to build a little street cred here. So FINRA, we've been around since about 1938 through an act of Congress as the NASD, and then we became FINRA. And our job is to protect investors. And we do that by promoting fair and equitable trade practices, and we adopt, administer, and enforce the rules set out by the SEC through all of the broker-dealers that are under our guise. So the few ways that we do that is that we actually monitor the market. And as you hear volumes change, that actually is a big effect on FINRA, because we have to bring in all of the volumes on almost every US stock market. And that can change from 50 billion a day to 100 billion a day, depending on the market. And certainly hardware was not an attractive solution. The elasticity of the cloud was. And as we do this monitoring and we monitor our broker dealers, unfortunately, we also have to detect fraud. We wish it didn't exist, but we have to detect that. And then we work to get restitution for anybody that was harmed due to broker-dealer activities. So some of the challenges that we have to do is that we're now grappling with an agile environment in the cloud, and we're trying to keep up. And the first thing to notice is that the cloud is just not this homogeneous cloud that you put on a Visio diagram, but it's really made up of a bunch of individual services, lots of them. Rohit spoke about a bunch of them. And what you need to do is to be able to look at each service independently and decide whether it meets your risk tolerance, and whether you can decide whether you can use that service or not. And how well you're able to manage those services is going to determine on how flexible or what kind of tool sets you're going to put into your application developers' hands. And we're going to show you how we do that with Splunk and AWS. Sorry, I missed a click there. So I'm going to start with one of the easiest examples, and this is something that probably everybody deals with the first time they get into the cloud. They find out that there's a service called CloudTrail, and CloudTrail is simply an audit trail of everything that is done in your AWS environment. So there's a lot of security and operational aspects to that data, and both teams would like to flexibly search it. And the way it works is, and I'm showing 3 AWS accounts here, and as you look at the accounts, each of the regions has an AWS CloudTrail turned on, and what we have is a central box here that's going out into an S3 object and grabbing that data at some polling interval. And what you find out is that this just won't scale. And you'll see other solutions in the market that do this, and when you have 3, maybe you can handle it this way. But when you have 33 accounts or 300 accounts, it becomes untenable. And so you need a way to be able to shift this left so that it becomes, it encompasses the 3 steps that I talked about. So how did we do that? Well, we took the advantage that AWS has that can tell CloudTrail to write to a central bucket, which is what we're doing here. We take all of the accounts and we tell it to write to this central bucket. And then we wrote a Lambda function that can easily scale up and down based upon the number of objects that are coming in. So I don't have to worry about the size of that polar. I then get the data into Splunk where it can be really easily searched by the people who need that information. So I'm able to actually achieve all 3 steps of shifting left. And what does it look like? Well, whenever a new region is set up, or whether a new account, it automatically configures CloudTrail. It automatically tells it to send its objects into that central S3 bucket. And so there's no hands-on. There's nothing anybody has to do. Then secondly, that data, I don't have to worry about resizing my polar box or what data is coming in, because Lambda will automatically scale. And there's no maintenance to it. I have no upgrades to do. It just works. And we've written it so that it auto retries. And price is always an issue when you're in the cloud. You have to look at those things. We baseline this for 415,000 objects. So that's 415,000 Lambda runs in a month. And it costs us less than a Big Mac to run. So you can get a Big Mac, which costs more than it costs to run that. And if you need more incentive to try this method rather than the old polar methods, we've actually open sourced it. So Katrina from our user experience team has created a really cool logo, and we've provided a link where you can go and download this Lambda function and do this for yourself. If you really want details on how it's built and what's in it, we presented this at .conf in 2017, and I provide that link. And one more thing is I provided a link because FINRA is very active in the open source arena. And so I provide a link where you can go look at all the tools that FINRA is providing in open source. Okay, so Patrick showed us a little bit about the details of getting a Firehose up and running. And let me show you how you can make it a part of your move to shift left, because we really feel at FINRA that AWS Firehose is a great service. It provides an economical way to reliably get your logs into Splunk. And let me show you what it looks like. So the first thing we did was we took the simple delivery stream and the Lambda function that Patrick had shown, and we built an infrastructure around it. Basically a cookie cutter that we're able to have a closed loop system in order to handle our logs. So Patrick showed that the Kinesis Firehose will reliably send any errors data into an S3 object, and it can do that securely using keys. And what we wrote was another Lambda function that will monitor that bucket. And if it sees errors, it will come up to the alarms to test the health of the delivery stream. And if the delivery stream is healthy, it will re-ingest the data back into the Firehose. So this thing will automatically fix itself. If alarm starts off, if somebody's dropped an SG, for instance, a security group, as soon as it gets fixed, the alarm will heal itself, and the cleanup function will automatically start sending the data back to the Firehose, where it will go into Splunk Cloud. So what does it mean when we shift left? Well, if I have we're going to look at VPC flow logs. A cloud engineer might want to start up a new VPC, and they'll upload a properties file into a Bitbucket, and a Jenkins jobs will run. And when that job runs, it'll build the VPC, and it will turn on VPC flow logs, and then it will create our subsystem, which is this little blue dot here. So the subsystem gets created, and automatically the data will flow directly into Splunk. Nobody touches anything. This cloud engineer has no knowledge that all this is happening, but it automatically happens where application teams can now determine whether their app is having a problem. Same with DevOps. If ever there's an issue, they can go out and see if there's a link that is having trouble, that is now being denied. And since we use Splunk Enterprise Security, all of that data is automatically running through threat intel for us, and nobody has done anything. Nobody has touched a single system. And this is what we mean by shift left. This is what we mean by keeping up, not having headcount to do day-to-day processing, but to make sure that it's baked in to the as far left into the SDLC process as possible. And is our VPC, let's also look at costs. I'm going to look at it pretty quickly here. So we do have Lambda costs. We have the delivery stream costs. So in order to get 100 gigs of VPC flow logs into Splunk, we will run that Lambda function 50,000 times a day. And that will cost us a mere $274 a year to run. And in order to ingest that data into Kinesis, that will cost us $445 a year. But we now don't need to store nearly as much data into our CloudWatch logs. We used to keep a year. Now we're going to keep 11 months of it. And what that means is we'll have a savings of $422. And what does that mean? It means that our overall cost to get 100 gigs of VPC flow logs into Splunk costs us less than $300. This is a pretty amazing thing from somebody who came from the old data center world, where if you wanted to build something like this, it would take months and months of time and many, many dollars. And VPC flow logs isn't the only thing that we use it for. We also use it to automatically ingest our Lambda logs for our developers into Splunk. We also use it for to provide input when SaaS providers give us an API so that we can load that data in. So we'll write a Lambda function to call the API and throw it right over to the Firehose, who can now reliably handle that data. We're also going to be rolling out a system that will do AWS RDS database activity monitoring, all using this same technology. And we just got a request, and we're going to honor it, to pull in AWS step function data for our application teams. And so now we can just cookie cutter this, and the only thing that changes is that little bit of Lambda code. So this is really a great win for FINRA, AWS, and Splunk. All right, let's move over to AWS ECS. So everybody's moving to containers. It's happening wherever we go. There, you can't get away from them. But there's a little bit of logging issues when we come to containers. And that is that containers, the way that they usually work is you put a driver on those containers. And that driver will actually automatically send all logs out to standard out. And that's okay, but what it does is it jumbles up all of the data. So if I have 5 files on this Apache container and 5 files on this Tomcat container, it will put them all out to standard out. And some of the drivers will put them into a JSON-like structure, apply metadata to it so that you could parse the stuff out, the log messages out yourself, but there's no industry standard for that. So moving from driver to driver is going to mean a lot of work. And what's problematic with it is that your SIMs or your log solutions aren't used to seeing Apache logs, for instance, in this new format. And you're left to try to untangle this mess. And what we did at FINRA was we said, let's take a different approach. As I now have these same Apache and Tomcat containers, and I have them in a single task, but automatically this little Splunk sidecar container gets started up. And also an anonymous volume is started up on the Docker space. So your Apache and your Tomcat will write to that anonymous volume, and Splunk is allowed to read from it and send that data into Splunk Cloud. So what is the upshot for us? for our developers, our logs look exactly like they did when they came from traditional servers. There's no redoing of dashboarding or alerting or reporting, because all the logs look the same. Our anonymous volume, as soon as the as soon as the container task goes down, it automatically gets cleaned up. And I'm not giving this nearly as much justice. It really needs about an hour and a half to go into all the intricacies of how much work we put in to make sure that this happens securely and reliably. But we now have about 97 applications that are leveraging this here at FINRA, and it's been a big win. So one last part on cost from that perspective is it only costs a little CPU for us to do that. And I've been harping on billing and on costs for most of this discussion, and because that is a passion or an obsession of mine, is to how do you manage costs in cloud? And many people try top-up or top-down approaches. Some try bottom-up approaches, but it's a difficult row to hoe. And I'm going to show you how we use some shift-left processes to be able to do cost management, not managing your bill, but cost management in cloud using some of the techniques we talked about. So the first thing that you have to realize is that you can't do effective cost management unless you have a lot of diverse data sets. So you can't do it just by pulling in your AWS bill. So from AWS, we'll pull in our detailed bills, we'll pull in our reservation. We also pull in the environmentals, the CPU, memory, those types of things for a lot of our compute. And we also pull in aggregations. So we'll run some Lambda code that will go out, let's say for a shared S3 bucket with, let's say, several petabytes in that several apps are using. And we'll do some analysis on it and send those percentages back into our preprocessor. But from FINRA, we also have the forecast from our project codes, from our project teams. We pull in valid lists of project codes, which project codes are associated with the reservations. We bring in the CMDB so we know the hierarchy of the teams. And then there are some adjustments occasionally to our bill, and we pull those in as well. And what is the upshot of all of that? Well, at the bottom-up approach, our project managers get insight into their environment through detailed dashboards that are customized to their app, and they can do drill downs and views that allow them to compare what their forecasts are to what their spends are. They get this every single day, and they can go in and look at it to see if any anomaly happens, so they're not waiting till the end of the month to get surprised by any cost. So they can make adjustments before anything would become a problem. Secondly, and this was a big win, is that the Splunk system became our financial system of record for our AWS billing. So we automatically send at the end of the month or at the beginning of the next month, we send the bills over to our financial department, and they're able to close in record time our monthly bill against for AWS. But really important is that the same data on the finance side is used on these dashboards so that there's again no surprises. They're both working off the same bit of data. And that's the bottom-up approach. So when we get this data in the project manager's hands, but a top-down approach is Peter Boyle's team that works at FINRA. We just have a couple of people, and they're just really, really talented, and they learn so much on Splunk, and they've understand billing, and they are searching all the time, squeezing our bill, looking for potential cost savings. And they're running searches, and they're comparing against environmentals. Are we sized correctly? Can we size down? Capacity planning in the cloud is completely upside down. We're actually trying to do capacity planning down, not up. And they actually become project partners. So they will meet with the project teams to ask questions to see if their how they could better utilize AWS resources. And we did a presentation. We've done a lot more since that. I provide a YouTube video of Siddhartha and I talking about a little bit more detail of how we accomplished this. So if you're interested, please feel free. So when you look at AWS services, it's not just whether it meets a business need. There are what I call overlooked cloud service criteria, and that is cost. Can I afford it? It doesn't make any difference if it meets a business need if I can't afford it. Can I do it in a secure manner? Can I support it? Do I have the operations? Can I stick this into a shift left where I can now get information to the support staff as quickly as possible in case there's a problem? And finally, can I surveil my configuration settings so I make sure nothing drifts? And we use Splunk to actually do all of these things. And so we use Splunk to manage our AWS services to help mitigate our risk that allows us to use more services. Those more services allow us to provide better functionality to the development. We put more tools in their tool case so that they're better able to serve the investors. And that's pretty much what we're talking about, is that we're providing the real time, we provide visibility in a cost-effective manner so we can protect the investors. And with that, we're going to open it up for questions and answers. Thanks for being tolerant and listening to me. I appreciate everybody staying online. Thank you. Bye.
Thank you, Gary, for sharing the great work FINRA has done using shift-left approach. We are now going to transition to live Q&A. You will be able to submit any written questions through the question panel. And in the event that we are not able to answer your questions today, we'll certainly follow up individually via an email. Gary, looks like we had one question from the chat referring to what does the Lambda function do? And I believe this question refers to the point where really error events from the Firehose are dropped into S3 bucket, and the Lambda function is able to do some analysis on it to be able to alert and push it back into Firehose. Can you please elaborate on that, what that Lambda function is actually doing?
Yes, I can do that. I'm sorry, I don't have the diagram in front of me. So like I said, if you look at you can pull the presentation from Splunk.conf 2018. We did that presentation there. Much more time we devoted to it than we could do here. So what that cleanup function does is it runs every 15 minutes and it says, are there any objects in the S3 bucket looking at the error prefixes? If there aren't, it goes back to sleep. And we run that every 15 minutes for a year, and it costs us the incredible sum of 11 cents to do that. Now, if there are objects, if there are errors, and this doesn't happen, it's extremely rare that we have a problem that something had changed in the environment, then it goes up and says, okay, I do have errors, but I don't want to re-ingest them into the delivery stream. I don't want to put that data back into the delivery stream unless I know it's safe to do so. If it's still in an error state, then that means that there's still a problem. So it goes up and says, let me go, it runs an API call and says, hey, for this delivery stream, are these alarms set? And if it's not set, it will re-ingest the data. But if it is set, it just goes back to sleep because the alarms have set off and have notified our operation control center that will let us know. Now, as soon as the issue at hand gets fixed, those alarms go down, and now the data comes right back into the delivery stream, and anything that you thought you missed is automatically re-ingested and goes back into the delivery stream and eventually into Splunk. So there's no hands-on. I hope that answered your question.
Thanks for explanation, Gary. Yet another question for you. How long did it take you to flesh out the billing/tracking functionality?
You know, I think that's so that is the number one question that I have is how long did it take? And I have to tell you, so we do some pre-processing, and I spent probably 3 weekends of my life writing that code and alienating my wife. But she allowed me to do it. So it just took a little bit for us to actually to pre-process that data a little bit before we got it into there. And after that, it was we had it up and running much more quickly than you think. Like, I mean, maybe the whole thing took a month or two, and then it took probably another 6 months for finance to be comfortable with it, for it to become our system of record. And so take it step at a time. If you get that data to your project managers, they're going to love it, and it's going to make everybody's life easier and make adoption much easier.
Right. And also in the same way, Gary, can you describe a little bit more about the environmentals? And also, how do you do the data governance on the project codes and other financial metadata that gets applied to your Splunk data set to AWS billing data?
So, okay, let me take what was the first one was, environmentals. So yes, in Splunk, we pull in, CPU, memory, and all those things. And at FINRA, we are like, we used to be, I don't know if we still are, but if not, we're one of the top EMR users, and it's transient EMR. So we'll bring up, and that's Hadoop as a service that AWS provides. So we might bring up, a big cluster with some big boxes at spot prices, and run it for 4 hours. But what it allows you to do is to reset your sizes at different intervals during the job run. So if I'm running a really big instance, I might want to bring the instance down after 2 hours. Let's say, because now I've done all my I/O, now I become more CPU intensive or memory intensive or I/O, whatever. But you can do that analysis, and that's how we marry that information to the cost of it. And we can actually look at those environmentals and make better decisions on when we can reset our EC2 types on EMR jobs. That's how we started doing that. But now we actually look at it for any of our infrastructure as a service, where we pull that same data. And we're actually looking at how we're going to be doing that for Lambda as well, because Lambda, I showed some really deep costs, inexpensive pricing, but that's only if you really manage it well. And a developer could slide up something and say use way more memory than it needs to, and it could end up costing the company. So you have to manage that really well. And the second question was, I'm sorry.
The second question was, how do you do data governance on project codes and financial metadata?
Yeah, so the idea is that all that stuff we pull in from the bill, the detailed bill, we'll pull those codes in, and all that information goes into, we'll actually run analysis on it. However, through the upper environments, our provisioning system also runs that. So no user in our entire environment could actually put in a bad project code, because we're running those things at deployment time, and then we run it afterwards. And that mainly affects our development environments, where we're a little less stringent on allowing developers the freedom to build. But we have something called the Thor of Hammer. I forget what the real term is, and your device will get shut down if you don't have it properly tagged.
Great, that's certainly a best practice. And can you also talk about how do you surveil your environments? Are you alerting against a configured baseline? Gary, can you elaborate a little more on that?
Yeah, that's another like 2-hour discussion. So we're currently working with our internal audit team and application team. And let me just put an overarching thing here. This is really everything that we're talking about here has developed security and application and DevOps to be a working relationship rather than anything adversarial. So what you see is if you shift left, you will move to a more working relationship, a better working relationship, because everybody understands where they're coming from. So when we surveil those things, and we did this at the Splunk Conf 2 years ago, so if you pull up that one, you'll be able to see it. So we like to use Lambda for that because it's event driven. For our infrastructure as a service, we use a product called Tripwire that's an agent that runs on our boxes. So that's how we ensure that our configurations on that type of stuff is there. Our DevOps teams pull lots of data on a pull basis from our AWS environment, and all that information comes into Splunk, and we run that so that we can provide that feedback if somebody goes out of if they drift. And so that is a work in progress, but it is moving quickly as we bring more and more things. We understand that surveillance is the most important way to do it. And my personal feeling is event-driven is the way to do it. It's the most cost-effective way to do it, and it's also the surest way to do it. So again, if you're pulling that data, you're probably spending too much.
Thanks, Gary, for that perspective. And another question for you: how are you collecting application data, app logs, infrastructure metrics? Are you using universal forwarders for that?
So what's it called? For infrastructure as a service, it's definitely, we're using a universal forwarder for that. We have we work with Daniel Ku's team here, who does a great job, as well as Kim Weiland's team, who's on the DevOps side, and platform engineering is Daniel's team. And we integrate that stuff into that's also all shifted left. So everything happens shift left. Everything is built through a provisioning process that checks to make sure everything's right, that they're writing the logs to the right place and everything. So we're able to actually get better control of that. And so Lambda, I think I showed both Lambda and ECS. We're doing that the same way. I'm sorry, we're doing that through AWS Firehose. And I looked at reInvent, and there's not a single presentation this year on AWS Firehose. So I hope AWS either looks to for FINRA to work with them, or that they come up with something, because this is such a cool service. It's so cost effective, and you will love, once you get through the first hurdle of doing your first one, you'll really love that service as a way to be able to pull that. Our application teams are coming to us. Step functions, we're building them now. They're coming to us saying, hey, can you help us get it in? And we have a solution that we can implement in weeks.
Great. Well, thank you, Gary, for great presentation, great content, and incredible achievements on shift left, using shift left approach. And also thank you, Patrick and Felicia, for talking about how Splunk is enabling customers gain real-time insights and stepping us through a demo. So on that note, we are going to wrap up today's webinar. As a reminder, you will receive an email within 2 to 3 days with a link to these slides on SlideShare and the recording of today's webinar. We want to thank you all very much for attending. If you have any further questions, please don't hesitate to reach out. Thank you.